Yo, what is up, guys? I just finished a 9-mile run. Are you guys proud of me? Tell me you're proud of me right now. I know you are. You don't have to tell me. Anyways, Chapter 10b, Study Guide. Let's get started. 10.5 is all about measuring the arcs or angles indicated. And so, in this case, notice that these two are given. And we want to find out what is this missing angle in the center. And remember, we like variables, so we're going to go with variables here. Well, remember, if you take the halfway point, basically the average of both of the arcs, so in this case, 50 and 210, if you take the halfway point of those, well, you're going to end up with the angle in the center. So that guy right there. So let's continue working on that. 1/2 times 50 plus 210, that's going to be 260. That's going to be equal to x. Well, that's like saying 260 divided by 2, right? Because again, this just goes under. And so 260 divided by 2, that's going to be 130 is equal to x. 130 degrees, if you want to draw that degree symbol, is going to be what this angle is. Number 2, same thing, except a little bit different. Look at the placement of the variable here. And so this variable x, let's change it to x, is on the outside this time. So we still need to take the average of what we just highlighted, the average of the two arcs. And the average, again, is just a fancy way of saying take the halfway point of both of those. In this case, it's going to be 50 plus x, right? So 50 plus x, that's going to be equal to the center. What's the center? In this case, it's 130. So 130 would go here. So 130. In this case, because we have a number and a variable, we can't really just squish them together. But what we can do is solve for it like an equation. And so let's get rid of this fraction by multiplying by 2 on both sides. What that'll allow us to do is these cancel. If we distribute 1 and 1, I mean, that doesn't really change anything. So let's just write it as if it goes away. So that's just going to become 50 plus x is equal to 130 times 2 is 260. Well, at this point, just solve it like a regular equation. These two cancel. You're going to be left with x equals 210 degrees. Back to this kind of question. Again, this one's kind of easy. If you look at the two arcs, and then you look at the angle in the center, well, again, you just take the average of the two. So if you take the average of 160 and 50, those are the two outside arcs, well, we know that that's going to be equal to the inside angle. So 160 plus 50, that is 210. Well, 210 divided by 2, plug that into a calculator, that is really just going to be 105 degrees. Nothing crazy to it. Moving on, so these are also having to do with finding the measure of the arc or angle indicated. Recall that this one is different in the sense that you have a circle and you have this little angle, right? It's formed by this line and this line. And the one that I just made is a tangent line, right? This one is called a secant line. Well, remember, this angle is going to be half of the angle on the outside. Half of the angle on the outside. And so if you think about it, they're telling you that this is 68. Well, that, if you double it, is going to give you 136, which happens to be this angle right here. Or sorry, the arc. Again, all you do is you just double it. That gives you 136. Well, that is going to be the length of this arc right here. Simple as that. I guess I'll just write my answer here. Okay. We're going backwards this time. We're given the outside arc. We're given the outside arc. That's going to be 98. Well, if that's going to be the outside arc, what is this inside angle here? We know that this number is already the doubled version of this angle on the inside. So in simple terms, just divide that by 2, right? I don't know why I wrote it like that. Let's do just 98 divided by 2. You don't need long division for this kind of simple thing. It's just 49 degrees, right? That'll be 49 degrees goes right here. Simple as that. Just, I don't know why I did that. 49 degrees. So let's write this as x. Again, in this case, x is just 49 degrees. Halfway. Or half of that. Okay, this is our only multi-step one, and there are different versions of this that they might throw at you. But let's say this is our angle. That's 85, right? Forgot to draw a little line here. In this case, I guess we're working backwards. Well, if this one points outward, well, that's going to be double 85, whatever 85 times 2 is. In this case, I believe that is going to be 170. So this arc is 170, right? This guy is 170. But that's not what they're asking for. They're asking you for this whole thing. That's what they're looking for. What is x? So recall, this is a whole circle. Remember? That is out of how many degrees? 360 degrees. Well, if you subtract away the 170 that we just found, right? This guy right here. Well, then you're going to get the remainder, which is 190 degrees. That has to be what x is in order to add up to 360, right? So that has to be 190. That has to be the answer. And again, if you can't visualize it, maybe just draw it on the side. You have a circle. It's cut like this. If this top part is 170, well, 360. Oh my gosh, that's ugly. Oh my gosh. 360. Oh my gosh, I'm having a seizure. That's going to be 190, right? That has to be the case for both of those have to. Dude, I don't know what I'm saying right now. I just ran 9 miles. Can you give me a break? There you go. You know, in other news, I'm actually quite sad about something. My brother's getting married next month, and I'm trying to like write the speech, and I can't do it. I can't bring myself to do it. Every time I think about it, I just want to cry. And, you know, I'm really close to my brother. If you're watching this and you have siblings, keep them close. Like, you know, just in general, enjoy the little things in life because one day you may look back and realize they were the big things. Yeah. Anyways, I don't know where that came out of. Let's do this problem, number 7. Woohoo. This one, I'm color coding it. Hopefully it's visible on the video. Recall that you're just creating a ratio between them, right? So you want to, let's work with this first. 10 times x. Those two we can multiply together. And then these two, which I color coded, 9 times 20. If we put those together, we have a little ratio as an equation, in which case we can solve for x. And so this is going to give us 180, right? And then at this point, it's simple. Just divide. You're going to get x equals 18. And Bob's your uncle. Remember Bob? There you go. That is x. And again, they're not meant to add up to the same number, right? They're meant to multiply to the same number. Again, moving on quickly. We're speedrunning this. Let's color code these. So 14, these two. This is a different color. Spice things up. Nice. So the green equations, once you multiply them, they're going to be 14x. The red ones, if you multiply them, is 21 times 12. Well, 14x is going to be equal to, these two are going to multiply to 252. To get x by itself, just divide by 14, divide by 14, boom, they're gone. X equals 18. Nice. We love Bob. Bob's our uncle. Let's keep going. So here we go. This right here, recall that we are still creating ratios, but this time we have two secant lines. Secant lines are lines that cut through the circle. Tangent lines, again, are different. They just graze the outside. In this case, if you have two secant lines, well, you just create a ratio between these two. So let's do 10, and then 10 plus 17. That's our first ratio. And then let's do, I don't know, 9 and 9 plus x. So 9 and 9 plus x. Distribute where you can. I think the right side you can distribute because it's a variable, right? On the left side, you can distribute, but it makes things a lot harder. So if they're all numbers, just simplify it, right? So that's going to give you 10 times 27 is equal to, again, if we distribute, those two become 81. We distributed, so 9 times x becomes 9x. And then at this point, it's just a matter of simplifying. So 270 is equal to 81 plus 9x. Subtract 81, subtract 81. These two cancel. Boom. 270 minus 81 is going to be 189 is equal to 9x. One last step. Let me write the answer here. The answer is going to be 21 is equal to x. 189 divided by 9 gives you that nice clean number. Okay. So again, this is just 21 is what it's saying. Again, to check your answer, if you plug it in, don't expect it to add up to the same number. They don't, right? This will become 30. This will become 27. So again, that's not a way that you want to check these kind of problems. Let's do it again. Same type of problem. I included 2 on purpose. So this and this, that's going to be, we'll start from the outside going in. So let's do 6, and then 6 plus x. That's going to be equal to 7 plus 11. 7 plus 11. And so this is going to distribute, right? That's going to become 3 times 36, That's going to become 6x. We don't need to distribute this. I'm just going to treat it like as if they just added up together. The left side stays the same. 7 times 18, I believe, is 126, because I'm just a human calculator. There you go. And these cancel. 6x is going to be equal to 90. And then at this point, all you have to do is divide. X is equal to 15. Easy. Okay, a little bit different. This one is not so much like if we were dealing with these kind of problems before, 2 secant lines. But in this case, you have a secant line and a tangent line, one that just grazes it and it just doesn't keep going, right? In this case, the tangent line, remember, this one is the one that you square. It's just going to be 12 squared equal to, and then you just do everything else the same. Here's what I mean. So 12, right? That's going to be 12 squared because that's a tangent line. It's just multiplied by itself. And then 8 times 8 plus x sounds good for me on the right side. So 12 squared is not 24. Remember, it's 12 times 12. That's 144. If you distribute these two, you're going to get 64. Distribute again. That's going to give you 8x. Subtract 64. Subtract 64. These are going to cancel. You're going to end up with 80 equals 8x remaining. Well, that one's pretty simple, right? Just divide by 8. and then 10 equals x. Bob is your uncle. That's it. Number 12, again, I included 2 of each problem just because I think it's helpful to have different varieties. If I color code it again, the purple represents a tangent line. That just multiplies by itself. On the other side, that's going to be 4 times 4 plus x. 6 squared is 6 times 6, that's 36. Boom, boom. That's going to give us 16 plus 4x. Subtract 16, subtract 16. That's going to cancel. You're going to get 20 equals 4x. Divide, divide, canceled. This is going to give you 5 equals x. Moving on to 10.7, this is the section on graphing. And honestly, all you have to remember for this is just opposites, right? Whatever the center is, just think of the opposite. Now, take a look. In this case, all you have to do, identify 2 things here. Let's identify what is the center, right? We want to identify the center, and then we want to find out what is the radius. Both are easy to find, but radius is obviously just a number, so it's easier in a sense. Be careful here. Even though there's 2 tiles here, each one of them is just it's just a halfway point. So just look at the units when you're looking at this. This is 1. So in total, this is just a radius of 1, right? It's like this is 0.5, this is 0.5. So again, radius is just 1. So let's write that down. Radius is 1. And then the center, maybe I'll draw a little radius here just to visualize it. And again, this radius is the same no matter where you draw it, right? No matter where you draw it, it's always going to be 1. So this is the radius. And then the center is this point right here. Well, what point is that? I guess we moved all the way to -2 and then went up to +3. So that's -2, +3, right? And so if you're going to write the equation based off of this, right? Remember what the equation is. The equation is going to be, where do I want to write it? It's going to be x minus h squared plus y minus k squared equals r squared. If you don't have this down on your study guide, I would highly recommend writing it down. And just to emphasize again, these negative signs are already inside of the formula. And so if you plug in a negative number, that's going to become a double negative. If you plug in a positive number, it's actually going to just stay negative in that. So let's do that right now. X minus h in this case is going to be -2. And then y minus 3, if we plug that in, squared. And then radius is just going to be 1. You square that. See how we got that? Well, that's going to give us x plus 2 squared plus y minus 3 squared equals 1 squared is just 1. And technically, this is our answer, right? Notice that -2 became +2, and then +3 became -3, right? And so it's the opposite. That's all you need to know. Which one of these matches? Well, it looks like answer choice D is the one that matches that. So let's do some magic. Hello? Can I grab this? Woo! How cool is that? There you go. That's the answer. Let's do 14. This guy is going to be the center. Where's the center? Just make sure you count. This looks to be the center. And you could tell by counting the radius. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, so there you go. So 2 birds with 1 stone. This radius r is equal to 3, right? So let's mark this. Let's mark this. I'm going to mark the radius. We just discovered r is 3. And the center, what is the center? Well, that is going to be, it went from 0 to positive 2. So it's just 0, comma 2, right? So using this information, let's do that again. X minus h squared plus y minus k squared is equal to r squared. I'm going to write the skeleton of our function right here, just like we're used to doing. If we plug in 0 and 2 and radius 3, well, x minus 0 again, that's just x squared. Y minus 2 doesn't change. That's going to stay. And then 3 squared, 3 times 3 is just 9. And so that's technically our answer, but once again, let's do a little magic trick. Where does this guy, which multiple choice does it match? This one. There you go. This is the answer. That is it. Moving along, this time they don't give you the graph, right? They just give you the information. So they gave you the h and k, remember, that represents the center, and they gave you the r value. And so x minus h squared plus y minus k squared is equal to r squared. Well, let's write the skeleton of our function, just in terms of what we're plugging in. This is going to be negative 4, and then plugging in 5, and then plugging in 3. I hope that negative 4 is clear. It's probably not. I'm sorry. It's late in the night. Well, this double negative, right? Double negative, that's going to become just positive 4 squared. We know that y minus 5 doesn't change. That's squared. 3 squared is just 9. And so there you go. This is going to be your next answer. Okay, number 16, very similar. Should I zoom in? Let's do it. So you have your h value, you have your k value, you have your r value. Again, think opposites. If you already know that, you could take the shortcut, right? You know that it's going to be x plus 8 squared plus y minus 0 squared equals 8 squared. I mean, if you're pro at this already, right? If you're not pro, again, I'm just going to quickly go back. This is like saying x minus 8 squared plus y minus 0 squared equals 8 squared. I'm too lazy to color code it. But anyways, that's how you get from here to here, right? And so one more step, x plus 8 squared plus y squared, no more parentheses necessary. 8 times 8 is 64. This would be your equation. But yes, even on this problem, even on the previous one, you can skip all these steps if you just notice that it's the opposite, right? Negative 8 becomes positive 8. 0, well, 0 just doesn't need anything. If you look at this one, negative 4 became positive 4. Positive 5 became negative 5. 5. Did you guys hear that? Hope you didn't. Chapter 11. Okay. Again, this is a precursor to the full chapter 11, where we're going to be dealing with many, many formulas. But we're getting a little head start with the circumference of each circle. Really good formula to know, just 2 pi r. Just don't mix it up with the area formula. In this case, we're looking for the circumference, which conceptually is just the length around the circle, the distance. And so 2 times pi times r, well, what is r? It's just 9 in this case. And think about it, you want to simplify the best you can, just good practice. 2 times 9 gives you 18. Put the pi right after the number. That's usually how it's done. Well, that's going to be equal to 18 pi on your calculator is 56.5 when you cut it off or round it. I forget which of these we round or not, but I trust that you guys know how to round by now. And again, this tells you the total distance around that circle is 56.5 miles. And length is one-dimensional, so it's technically an invisible 1 up there. You don't need to write that. But area, remember, you do square it. Number 18. Again, be careful on your test. Two things. Just read whether or not it's asking you for circumference or area. And then 2, determine whether or not it's the radius or not. In this case, think about it. You need 7.4 divided by 2. You need the radius, which is half of that diameter. They didn't give you the radius. So this is 3.7. And again, we need radius because the main formula that we like to use is 2 pi r. If you're using the other formula, then I guess you can just do that. Honestly, it's just better practice to use the formula with radius because all the other formulas we use are radius. So 3.7, that's what we're going to plug in. These two multiply. Yes, if you notice, we get 7.4 again. But again, just better practice to use the radius formula. 7.4 pi, well, that is approximately 23.2 kilometers. Nice. Exciting. Okay, length of each arc. Let's move on. Again, length of each arc, just think about arc as just a section of the circumference. It's not the whole thing. So this guy right here is an arc. If we had the whole thing, that would be circumference, but part of that is just called the arc. And so the formula is a part of c equals 2 pi r, okay? But the reason I'm writing it all the way to the side is because it's a fraction of it. It's a fraction out of the 360 total degrees. And how much of a fraction is it? Well, it's 210 degrees out of the 360. So at this point, let's plug in something for radius. Bye, radius. Woo! So radius, we're going to plug in for whatever that number was. In this case, it's 20, right? So working with these, before you plug it into the calculator, you generally want to simplify as much as you can. So 210 over 360 times 2 times 20. Well, that's just 40 pi. And then whenever you multiply a fraction with just a whole number, well, you multiply the numerators. So, and again, that's because technically there's an invisible 1 here. So 210 times 40 is 8,400. A lot of you guys forget to put pi, but again, that's the key ingredient, okay? Divided by 360 didn't change on the bottom. Well, if you punch this into a calculator, you could immediately get the decimal. I'm going to write the intermediate step where it simplifies the fraction for you, right? So this is the fractional answer. But the test is going to ask you for the decimal approximation. So 73.3 centimeters is going to be your arc length. That is how long this purple. I don't know what color that is. Let's call it purple. If you look at this again, last one for the type of arc length. So circumference is going to be times 2 pi r, but recall that we're just looking at a fraction of it. 360 degrees, how much of that? Well, 60 of that. So let's plug in radius. In this case, radius is 13. Goodbye. Whew. That's going to give you 13. And so simplifying this, you're going to get 60 divided by 360. If you simplify 2 times 13, you're going to get 26 pi. Multiplying these two together, 60 times 26, that's going to give you 1560. And don't forget the pi, it needs to drop down. And then 360 on the denominator, didn't change. Punch that in a calculator, it'll simplify the fraction for you, 13 pi over 3. And again, if you click SD on the calculators in my classroom, it'll give you the decimal approximation, 13.6 meters. Okay. All right, home stretch, last couple. questions. 11.2. The area. Let's highlight this. Area is going to be pi r squared, right? And so pi r squared, that's the area formula. It's really worth, learning at this point. Well, area is going to be this shaded region inside here, okay? And so if we use the radius that they gave us, ooh, terrible color, that's going to give you pi, and then 7.4 is your radius. Now, if you do 7.4 squared on the calculator, don't forget you could press SD to get the decimal approximation. 7.4 is going to be 54.76 pi. And then once you square it, and then that on a calculator, once you approximate it, should be about 170.0 inches squared, because area, recall, is two-dimensional, right? And again, I'm just going to quickly talk about this real quick. If you just have a straight line, again, that's just inches. If you have, let's say, like a box with area, that's inches squared. If you have a box, right, but it's three-dimensional, volume, that's going to be inches cubed. Simple as that. And we're gonna learn about the difference between all three. But area is two-dimensional is my point. If we look at this, again, be very careful. You notice that this right here, your radius, oh no, your radius is half of that, right? Radius is half of 6, which is 3. Just divide whatever number that is by 2. That's going to give you 3. Your area formula does not change, right? Your area formula is still pi r squared. And again, be very careful. In this case, radius is 3, not 6. And so pi times 3 is 9, which is like saying 9 pi. Well, on your trusty calculator, that should give you 28.3 yards squared. Nice. Let's keep going. 11.2, find the area of each sector. Area of each sector. So sector, just remember, that just means something like section, right? So in this case, we care about this section right here. Oh gosh, how neat can I? That is horrendous. That is terrifying. Oh gosh, I'm sorry. I'm gonna clean that up the best I can. Nice. Artiste right here. Do you know I'm pretty good at drawing? Check this out. This is the face that I always draw on my papers. I always do this little side profile. Ooh. Ooh, look how fast I can do it. I messed up the teeth, but it's fine. You watch Naruto? Well, let's make it Naruto. Do a little headband, dot, 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 dot. And then draw a little hair. Dude, I am going crazy. I need to finish this. Draw a little stubble. There you go. Nice. Let's move on. Area of each sector. Recall, this is the area, not of the whole circle, but this is just a section of it. Just like before, a fraction of it, if you will. How much are the fraction? Well, in this case, 270 degrees out of 360. So let's poof this radius away. Radius is 10. So we're just gonna swap that guy out. This is messy. In any case, 10 squared. Well, this is going to just drop down 270 over 360 times, what is 10 squared? Let's just write 10 squared. 10 times 10 is 100. And then pi. And then you could multiply the numerators together. You're going to get a pretty big number. This is going to be 27,000 pi over 360. This is going to give you 75 pi. And then in this case, 75 pi, if you plug that in, that's 235.6 yards squared. I'm going crazy. Again, I get this question a lot. Where did I get this number from? Look, it's just a calculator simplifying it for you. I mean, you can do that yourself, but the calculator does it for you. Like 27,000 divided by 360 gives you 75. And then again, the pi just drops down. Last one. Again, this gives you another sector. Boom. You know what? Check this out. Life hacks. If I do this, boom, genius. That is so much. You're cutting out that chunk. There you go. Oh, beautiful. Pi r squared, well, a sector of that is going to be out of 360 degrees. How much degrees? Well, 270 of it. Let's, I'm just going to move this guy away. Goodbye. You're banished. This is going to be 9 squared, because the radius, again, is 9, right? That's where you got 9 from. And so if you simplify this, 270 divided by 360, again, you could simplify that fraction if you wanted to. In fact, you could easily cross out the zeros. I'm looking at it right now, but for the sake of simplicity, I'll just keep it. We know that 9 squared is 81. Pi comes down. You can multiply these two now. So that's going to become 21,870 pi over 360. Punch that into a calculator. Just straight up smash that into the calculator. Punch it. I mean it. Just give it a big... Okay, anyways. 300 and... No. I need to finish this. I'm so tired. This is divided by 4. This will simplify that on a calculator. And that is going to give you 190.9 centimeters squared. And that's the area of the sector, right? Most important question today. What do you think is something that is important to Mr. Chung? Is it running? Is it Jesus? I do love Jesus. Is it, I don't know. I feel like I have so many hobbies. Guitar? Swimming? Life's great, guys. Just enjoy it. I think in simplicity, I'll end it on a cheesy note. It's you guys. Woohoo! You know that emoji I always draw? What's that face? It looks kind of like this. And then, there you go. Oh, dude. I don't know how to do this. Peace sign? There you go. Yay! Let's highlight it. That's the most important answer of it all. I know it says answers may vary, but that is what I am going for, okay? Whew. What's important to you?